Greetings, welcome. So you can already see, I'm going to go through a mean value theorem example, and I've already kind of set this up for us so that we can just spend time solving it instead of setting it up. So we're going to look for, so I talked about in this mean value theorem, we're going to also abbreviated MVT, okay? We're going to know that there's going to exist some point in that interval whose output is going to give us the average value for the function. So the question can be, well, what is that point? So we can solve for it sometimes. We're going to do that in this lecture. So we're actually going to find the value c. So this is our value c. This is our interval AB that we're going to be looking at. Oh, this should actually be 0, 1. We know what it is specifically in this circumstance, but that kind of highlights the fact that that's our A and B. So no danger in that. So I want to know on the interval 0, 1. So it's drawn in this picture where we have the function f of x equals x times 1 minus x. So this is the graph of the function. We're looking for, right, so this area here, so f of c times the length of the interval should give us that same area as underneath the integral, right? If we move the b minus a to the over to the other side. So this is the correct picture. Something to notice about this is going to be, it's going to be kind of symmetric here and go up and down. So we're going to expect to have two values because you're going to have two values that are going to give you the same output. So that f of c is going to be the key kind of average. That's going to give you the average there. Okay. So let's go ahead and work on solving that. Okay, so we want, right, so what we're aiming to have is that this f of c, I might want that color. So we want to use that this f of c should equal the integral of 1 over, this is kind of what we want to use, but we know what these, a lot of these are going to be, so that's going to be okay. B minus a of the integral from a to b of f of x dx. And I'm kind of a little bit in the way of this, so f of x dx. Okay, so we want, when I say want, I want like want to use. This is what we mean by this. Okay, so now we just kind of plug everything in here. So what is it happens when I plug c into there? So I'm going to get c times 1. Okay, so c times 1 minus c. Because this is how this function works. Actually, this should be blue. This time I didn't drop a pen. I dropped the remote that makes you zoom in or out. Okay, so we have c, and then there's going to be a c here, and this is, we're just using this function here. It's kind of clear if I, okay, so I plugged in the f there, and then on the other side I have, this is going to equal 1 over, and then we have our b minus a, so that's our 1 minus 0. And then we have this integral from 0 to 1. And now we can put in our f of x, so that's just going to be from up there again. So this is x times 1 minus, I'm having troubles writing things correctly, 1 minus x dx. Okay, like this. Oops. This is coming a little bit off the side. I made a new mark for myself so I know how far I can go, and then I didn't look at it. Okay. There we go. That should stay in now. Okay. And now I can go through and actually start computing these things. So I'll just, now that we kind of know what corresponded to what, I can just work through with the without colors. So let's just go ahead and do that. So I know, so let's just keep this over here. So I have that c times 1 minus c is going to equal, well, this ends up being 1. right? So I have 1 times the integral from 0 to 1 of, and then this is still x, 1 minus x dx, which is going to equal the integral from 0 to 1. And then let's just, we know how to integrate polynomials, so we're just going to expand this out so it's a polynomial, so we can integrate it. So I have x minus x squared dx. Okay? But now I can actually compute this integral, right? So this is going to equal, right? So I have this one, so I have to have x squared over 2 minus x cubed over 3 evaluated from 0 to 1. Okay? Which is actually going to equal here, well, I'm going to put in 1 here, so I'm going to get 1/2 minus 1/3. So this is going to equal 1/2 minus 1/3. And then I'm just going to get zeros from that, right? So this is all going to equal 1/6. Okay. So I kind of did that over there. Oh, again, I'm using the wrong, how much, can you see? There we go. That you can all see. Okay, great. And again, you can look at the notes if you can't read it on here. Okay, so then let's keep on working through from here. So to the next step. So now I'm going to go, so I have c times 1 minus c equals 1/6, right, from all of that, which gives me that c minus c squared equals 1/6. Which gives me that, so now this is just a quadratic, so I can bring it all to one side, so I can get, I'm actually kind of bringing it to that side, but this is just a quadratic. I'm just bringing everything to the same side. And then have that it equals 0, and I can just use the quadratic formula to give me that c equals 1 plus or minus the square root of 1/3 divided by 2. Okay? So just to kind of emphasize, I use the quadratic formula. Okay. And then the thing to now check. So check that both of these are actually lie in our interval. So that's the next part. Check that both are in 0, 1, which they are. So I get a final answer, which is that c equals 1/2 plus or minus 1 over 2 times the square root of 3. Okay. So this is an example where we kind of work through to understand. I think that sometimes actually working through these examples helps you kind of a little bit to understand how to focus in on the different parts of the theorem, even if you wouldn't maybe need to know where the value c lives. But even still, having had to work through it kind of might imprint in your mind that you're actually looking for an x value. I didn't ask you for the f of x value, things like this. So it can be really good to kind of go through these examples. But the emphasis is that, okay, so but we can do this where we actually do solve for the c. That gives you the, so that f of c is the average value. So this is kind of what we want. We just kind of plugged in our functions. And then we're solving for the c, so I don't have anything to plug in there, but I do have the 0, 1 from the interval and my f of x there. And then I just start solving. So this equals, that's just 1 over 1, so that's 1 there. I didn't do anything here. Now I start to integrate. Why did I multiply this out? Because it becomes a polynomial, and then it's easy to deal with. And then we know that now we're taking antiderivatives. So I have x squared over 2 minus x cubed over 3. And I have to evaluate that at both 0 and 1. So 1 squared gives me 1. 1 cubed gives me 1. So I have 1/2 minus 1/3. Then I subtract off, applying this whole thing to 0. So I get 0 over 2 minus 0 over 3, which gives me 1/6. Okay, so now I have that c times 1 minus c is going to equal 1/6. So now I have to solve for c, but I'm in good shape because it turns out that it's actually just a quadratic. And we know how to solve quadratics because we have the quadratic formula. Okay? And that's all we did there. And so that's how we got our final answer. Okay? So this is a nice, useful theorem. It has real, like, kind of implications or applications. And I've just kind of showed you how you could actually find that value, at least for a nice function. But, you know, if not for that function, a lot of times once you have an equation, you can look for the roots on a graph or something like that. Okay, so great. So I hope this made some sense and that I will see you in the next lecture.